Okay, we continue doing the homework for the section 6.4, in this case the problem 75, que es f of x equal ln 2x minus 3. Es obvio que the domain of f is the expression. You take the expression inside the logarithm and must be positive. Divided by 2, both sides, x is greater than 0. This is the restriction. It's all real number positive. Okay? Okay, this is the domain. Now let's see the graph. Okay, let's start for the basic logarithmic function. So basic ln x. The typical point, reference point, is this point is 1, 0. And we have one vertical asymptote at x equals 0. So approximately the logarithm function look like that. ln x. Now we are doing the transformation. The transformation is ln 2x. You put the factor 2 inside the parentheses, and it's a typical horizontal compress. Why? Let me try to explain why. This is, for example, this point is moving like that, divided by 2. Why divided by 2? This point is the point half, 0. Because when you plug in half here, 1/2 times 2 is 1, and logarithm of 1 is 0. Okay? For the moment I forgot this 3 because I consider step by step. Okay, now the new curve look like that. Occur the horizontal compress. Now finally minus 3. Minus 3 is go down this point, go down 3 units. 1, 2, 3 here. This point now is 1/2, -3. Okay, entonces the entire curve go down approximately like that. Okay, this is the ln 2x minus 3, and the rest is not important. Let me erase the rest. Okay. Okay, let me try to put another color and emphasize the idea for the original. The original is this. Okay, wait. Magenta. Okay. This is the original. The original, no. This is the transformer. Approximately. Okay. Now, look in the graph. You can see the range of f is obvious, it's a real number. Look at the graph, because cover everything in white, positive and negative. And what more information they want? Well, they want the inverse function. Let me try to find the inverse function. Okay, inverse function. Inverse function, remember, is I copy y equal ln 2x minus 3, and you interchange x and y. That is x plus 3 is equal ln inside the argument to y, so you find the exponential both sides. X exponential x plus 3 is equal to y, then y, new y, que es the inverse function, is equal 1/2 exponential x plus 3. So you multiply by 1/2. When you multiply by 1/2, of course the vertical compress. Now, when you x plus 3, you put x plus 3 is a horizontal shift 3 unit, but to the left, in the other direction. Okay, now let's see what happened. The point, this point, que normally is a point 1/2 comma -3 would be -3 comma half positive, and -3 here, -1, -2, -3, and half is a 1 is here. Now one more time, we have one horizontal asymptote here, horizontal asymptote at y equals 0. Now using the blue color and different, we have this is okay, and wait, this is the approximately the identity function y equals x. Now using another color, this is the exponential. The exponential look like that. Okay, and this is the inverse function. And the expression for the inverse function is equal 1/2 e to the x plus 3. One more information we need. We need the domain of the inverse function, que is equal to the range of the original. It's a real number. It's logical because it's an exponential function, and the range of the inverse function is y, such that y is bigger than 0. And that's it. This is 75. Okay, now 77. Okay. Let me erase this part. Okay, erase. Okay, 77 then. Let me copy the 77. 77 is f of x is equal logarithm x minus 4 plus 2. Es obvio que the domain of this function is all real number except the restriction inside. You take the expression inside must be positive. X must be 4. The restriction is x greater than 4. Okay. Let's do it in the graph. The graph is xy. Okay, in this case is the base es omit, entonces you suppose default que estén, que eso es como logaritmo. Okay, but the most important is not this, is the transformation. Okay, the typical logarithm is 1,0. This is the reference point, and the code look like that. logarithm x. But in this case we have minus 4. Minus 4 is typical horizontal, so logarithm x minus 4 is typical horizontal shift 4 unit to the right. As this point is moving, so then is 1, 2, 3, and 4 more. This is 5, 0. And of course, the asymptote is located here. The vertical asymptote is at x equals 0. Now would be here. And this is the vertical asymptote, is vertical new asymptote is x equals 4. Now the color look like that. This is 5, 0. It's moving like that. This is logarithm x minus 4. Plus 2 is plus 2. Plus 2 is logarithm x minus 4 plus 2 is a vertical shift 2 unit over. And at this point, que normally is 5, 2 would be 5, 2 here. This point is 5, 2, and the vertical asymptote stays the same. Okay, so now this is our core. Let me use another color. We use a magenta always. More bold, a little bit more, like that. And this is the graph, and this is the typical reference point we are using. Okay, now let's come back to the black color. Let's do in the graph of the identity function. Okay, it's y equal x. Okay. Now, alright, look in the graph. I saw very well the range of function f is a real number because cover all real number, positive and negative. Okay, now I want to erase this part. Now let's compute the inverse function. The inverse function is y equal logarithm x minus 4 plus 2. Now interchange x and y. This is x is equal logarithm y minus 4 plus 2. X minus 2 is equal logarithm y minus 4. Now the base is 10 on those each other, and on those the logarithm and the exponential. So far we have 10 x minus 2 is equal y minus 4, therefore 10 x minus 2 plus 4 is equal y, que es the inverse function. This is the expression que represents the inverse function. And of course this inverse function contains one horizontal asymptote and 4. 3, 4 here. This is horizontal asymptote and y equal 4. And this typical point, let me use another color and the trace a little bit more intensive, is blue. This point normally is 5, 2 would be 2, 5. 2 is here and 5 is here approximately. This point is the point 2, 5. And I try to do the sketch a little bit symmetric about the y-axis and include the asymptote. So this is look like that and like that and like that. And this is the horizontal. Okay, then the domain of inverse function is the all real number. It's all real number because it's exponential, and the range of the inverse function is y, such that y is greater than 4. Remember, it's exponential, but it's only range is available after the 4. So don't touch 4 because it's asymptotical. It's from 4 without touch 4 and infinity. Okay, that was 77. Good. Okay, homework of the section 6.4, problem 71 is find the domain of f. Okay, remember the restriction. The restriction is x plus 4 greater than 0, x greater than -4. Now domain of f function is all real numbers such that x is greater than -4. This is the domain. The second is do the graph. The graph is, look, x and y. Okay, we have one vertical asymptote and -4, -1, -2, -3, -4. In -4 we have a vertical asymptote, and the asymptote is x equal -4. Vertical asymptote. Now typical point. Suppose -3. -3, -3, -3 is -3, 0, because -3 here is -3 plus 4 is 1, logarithm of 1 is 0. Okay, now the curve look like that. This is look like that. Okay, it's a typical ln x plus 4. It's obvious it's a transformation. We have a horizontal shift 4 units to the left, and from the graph determine the range. Okay, range of f is obvious it's all real number. Look at the graph, it's obvious it's all real number. And range and any asymptote of the f. This is the only asymptote that we have, vertical asymptote. Find the inverse. Okay, let's do the inverse. The inverse is y is equal ln x plus 4, interchange x and y. Okay, so for y, to say you compute exponential using base e is e to the x is equal an exponential and logarithm of the same base cancels out each other because its inverse function, its identity is only y plus 4. And so for y gets the inverse function, so the inverse function gets the new y is equal exponential e to the x minus 4. And then find the domain of the inverse. It's obvious that the domain of the inverse function is all real number for two reasons: because it's exponential and also because it's equal the range of the original. And graph the inverse. Well, graph the inverse is easy because we have then one horizontal asymptote and -4 here, -1, -2, -3, -4 we have here. Horizontal asymptote, y equal -4, and this point is a point 0,3 here. And this is symmetric with respect to the line y equal x is 0,0, 1, 1. Okay, this is something like that. This is the identity. Okay, help me to do the graph. Okay, so now the graph look like that. Suppose it's this, something like that. This point and this point also is common. Okay, and this is e to the x minus 4, que es the inverse function. Okay, one more information they need, the graph, and why no? The range of the inverse function. The range of the inverse is, you see, look at the graph, it's easy to see, is from -4 to infinity, don't touch -4, and also looking in the domain for the direct, the range is y such that y is greater than -4. Done. This is the complete answer. Okay. Let's see then. 73. Let me erase this work. Okay, ready. 73 then. 73 is, the function is f of x is equal to plus ln x. Okay, the first job is find the domain. Domain of f function is, okay, is when the x is greater than 0. So the restriction is x, this expression inside the logarithm must be positive only. So says x such that x must be positive. Okay. This is the domain, is the first part. The graph. Let's do it in the graph. X and y. The graph of the basic logarithm is, you know, the classical point 1,0. We have here a vertical asymptote. Now the transformation is +2 is a vertical shift to unit. So this point is 1,2, 1,1, 1,2. Approximately, this is the point 1,2. And the graph look like that. Okay, this is 2 plus ln x. This is one typical point, and the asymptote. One more information they want. They want to determine the range. Okay, determine the range. The range of f, look in the graph, it's obvious it's a real number. It's obvious here, cover, positive, negative, 0. Inverse function. Inverse function is y is equal to 2 plus ln x. So for, okay, interchange is x is equal to 2 plus ln y, and interchange, so for y, sorry. This is x minus 2 is equal ln y, exponential function both sides is e to the x minus 2 is equal y. Is inverse function. Okay, in other words, the inverse is e to the x minus 2, that corresponds with the horizontal shift to unit to the right. Okay, so this point normally is 1,2 would be 2,1. So it's 2 here and 1 here. And the line identity is this and this. The line identity look like that. This is the y equal x. And this is a point is symmetric. Another point is this point when they're both core intersecting. Now we have, in this case, the horizontal asymptote is here, doesn't change. This is the horizontal asymptote and y equals 0, and this is the vertical asymptote for the original and x equals 0. This is the graph that corresponds with the exponential x minus 2, que es the inverse function. One more information they want. They want domain of the inverse. Domain of the inverse is obvious que it's a real number because it's exponential and also it's equal to the range of the original function. And the range of the inverse is y, such that y is positive only. It's obvious que it's only positive and no include 0. And the graph I did, that's it, no more.